Yo. What's good to you, everybody? So yesterday, we started to dive into Bittensor, TAO token, which is a little complex for a lot of people, but effectively it is combining cryptocurrency and AI together. And one way you can think about this is like Bitcoin and the compute power around that is utilized to solve the next block, that mathematical algorithm, right? Well, that energy, once it's solved and all the energy that was put towards it just kind of goes away. But what if it was proof of stake combined with proof of work and all the energy associated with solving the problem, solving the next block, getting the inflation in the system didn't go to waste, but went to the miners in the system that added the most value, right? Instead of just solving the next problem, like what you do a computational problem in Bitcoin, what if that computation wasn't for mathematics, but it was who can add the most value to the network in terms of increasing the intelligence of the network? And you have these mesh of crypto and AI brought together to create another network where if you contribute knowledge or information or the increase in the system's intelligence of the network, you get rewarded for that. Versus like how things are currently set up right now, where you have researchers in all these dispersed parts around the world that are not collaborating together. And they're doing research. I might be doing the same exact research here, but we're doing it independently, which means we're not collaborating. When you get collaboration, you get increase in speed, and you get in terms of the speed of the growth of how fast something happens, right? And this is the like frothiness before the masses come in, right? This is what's taking place. We've all heard about ChatGPT. We've heard about all these different AI art things that are coming out. AI is eating up all sorts of stuff. And I actually want to get into two things quickly. So this is from Google Trends. Google Trends is the tracker for search volume on Google and on YouTube, right? So they're the largest search engine in the world. That means people are querying Google to learn or get information. And you get to see what they're querying, right? So we just put in here over the last 5 years, or since 2004, artificial intelligence, right? AI. And you get to see that on the web, it was like high back in the, like, when was this? 2004. I don't really remember what was happening around 2004, but something was happening clearly, because when they started tracking it, there was something that was taking place around that time. Maybe that was when like Siri, no, that was actually before Siri. I'm not sure what was happening, but you get to see this swell in terms of search volume, right? Up and to the right. Let's go to YouTube. Also, not as much of a trend, right? But it does look like it's up and to the right, but it's just ever so slightly. But what is more interesting than the data here, because these are some resources that I turn to when I'm trying to understand what's going on. You know what an exponential curve looks like, right? That's one of those curves that goes like very slow, and it starts out like this and then just goes up and up and up and up like that, right? That's an exponential curve. Well, there is another resource that I turn to called NCBI. So I read research papers for fun because I'm a fucking nerd. And over there, you can put in a search term, and then it's the largest database of research papers of all different topics, right? So you can put in a topic, and then you get to see how many papers are released or added to the network per year, right? So I like to use this as a gauge to understand the intellect's interest in a topic, right? And if you look at this, so this is NCBI, right? Artificial intelligence. The National Library of Medicine is what's up right here, but it's pubmed.ncbi.nlhm.nih.gov, right? If you just search NCBI, you'll be able to find this. Check this out. This started out, right? Exactly like I said. Starts out super, super, super duper slow, right? Very, very slow. 1950s, they started adding papers about artificial intelligence. And it just looks like it's just flat for decades, right? And then we start seeing some growth. What is this? This is 1978, right? We see some, 87, I think that was. 84. We see it start to grow in the 80s, right? Start to increase in growth. More and more papers are coming out, right? In 1999, there was 1,000 papers that were added to this database, right? Let's see, 10 years later, there was 4x, right? So there was 1,000 papers added in 1999 around artificial intelligence. In 2009, so 10 years later, there was 4x, 4 times the amount of research papers added. So what's like the significance of this? Well, DARPA, right? That's the funded by the U.S. government for military and other type of research. But more importantly, universities, right, around the world do research, and generally they're going to be funded by institutions or companies or grants from the government, right? Parties who are trying to solve a problem that they don't know how to solve. They don't have the resources, the know-how to solve the problem, so they give grant money to a school to do research, or in the case of like the fake pandemic over the last 2 years, right? Give research to help sell your drugs or force it upon people, right? Things like that. So to see a 4x increase, in 10 years. Now, that's not even the interesting part, right? So from 1999, 4,600 over a 4x. Let's go to 2019. 2019, we see another 4x. Right? So you're like, okay, 4x, that's not going to happen again, right? And yet we have a 4x, and then we have another 4x on top of that. And where does this chart look like it's going to go? Up and to the right. So we have from 4,000 research papers to now 16,000 research papers. And we're going to get into all of this and what all this means with the Bittensor network by understanding several pieces around it. We got a paper to take a look at. We have several videos to take a look at. We're going to get into all of this kind of stuff because it is fascinating. I think this could be very, very interesting to see how this plays out because it just launched recently on the parachain associated with Polkadot. So see you guys in 1 minute and 9 seconds.
You already know what time it is. Crypto in the morning. Crypto in the morning. Crypto in the morning. Waiting on phone. Crypto in the morning. 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 Waiting on phone. Crypto in the morning. Crypto in the morning. Smoking no blunt on my way to the gym. 11 a.m. and I'm already tuned in. Got me some hacks and I'm making a stake. Got me some heads on, I'm making it rain. Pay me some maxi and that's just in case. Jim ready sent me to show you the way. Crypto in the morning, 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 crypto in the morning.
Drive carefully, honey. So let's get right into this. So yesterday we left off with Matt Hamilton, right, who is one of the guys behind or working with or on the Bittensor network. And his keynote, this was from June 29th, 2022. So a lot has changed, right? They actually just won their auction on the Para network or Polkadot. We can do another video on that to understand how that's doing it, because this is something I'm super curious about. So let's get back into this video where Matt is going through and trying to show what is going on with the Bittensor network. Then we have some other paper to get into. What is a neural network? What is supervised and unsupervised learning? And then the big piece, which is going to drive adoption for price performance, right? What's going to drive the value of TAO up? I found this small little YouTube channel by the Cryptorian, and he has it on here. Why would corporations leverage the Bittensor network? And that'll be interesting to see his take on there. So let's first get into this video, and then we'll move forward. What's up to everybody in the chat as well? Thank you for stopping by.
And go via then. But that's the bit that's kind of bringing Web3 to AI. It's the decentralized, permissionless aspect of it. It means anybody can not only contribute, but anybody can query and use the network. So a little bit of an example here. So this is going to be a screencast of a Python notebook.
Sounds super. It looks like very intense to get right into something so detailed, but bear with it because this is part of the understanding of how the network works.
Running and querying a machine learning model. So if I start it there. There we go. So we're importing the Bittensor libraries, and we're syncing what's called the metagraph. We're connecting to our testnet, which is called Nobunaga. And you can see it synchronizes with the network. We then, the next line down below, create a wallet. I've got a test wallet that I'm just using here. We select the network. So this one's 55, which is a model from an entity called Eleuther. And we are, it's going quite fast here. We're sending a sentence. The quick brown fox jumps over the lazy. It sends it to the network, and we get it back. We can run it through the tokenizer to get the results back, and we get the prediction dog, right? So
what this is effectively doing is showing you how you could use the network, right? They call it an LLM. They have two different kind of white papers, one that is like very quant or math, and then one that is more qualitative. And so I read through this. If you guys care to check it out, Incentivizing Intelligence, the Bittensor approach. And you're like, okay, cool. This sounds interesting. We know AI is popular right now. We know crypto is popular. Both of those things are growing very rapidly. But like, how does that relate to the user? Well, what he's going through and showing right now is how somebody could do a query on the network, similar to how you can do a query with ChatGPT, right? But you end up having to utilize the TAO token in order to actually go through and do that. So let's see what he gets into in the next section here. Where was it? He jumps through. Here we go. This is where we left off. So if some of this is not making sense, you should definitely check out yesterday's video.
But that's an example of querying against the network, Nobunaga. So what's coming up? So synapses, that's what I've just sort of demonstrated there, allowing multiple modalities and easier inference on the network. At the moment, you can do inference, that's querying the network. But what you get back is basically a bunch of stuff that's really only readable. You get back what's called a tensor, which is basically an array of numbers, which is really only, you need much more post-processing to make that useful. Synapses will give you what we saw there, the actual tokenized output come back. And it's a common format for all models to use. So we can actually have models that, like I said, process images, process text, video, etc. And then the other thing I've also touched on is parachains. So we're going to be connecting to the main Polkadot chain, hopefully later this year. And that then allows the currency TAO to be traded, access to DEX.
So let's see here. Somebody just mentioned this. JB, yes. So it's trading around $40 last time I checked. And you know how like we're in a bear market, so a lot of shit's down 90%, right? In the bear market. Well, this started trading. I don't remember the time frame, but it started trading at $5 not too long ago. It's on the Bittensor network, which is not their network. I'm sorry, Bittensor Exchange is what it's called. Let me show you this real quick. So on this network right here, it's called, and I'm not saying you guys should buy this. Like I don't own any of this yet. I'm learning about it actively, and I might be opening and or building a position in this because this is fascinating to me. But check this out. Okay, so this hasn't been along for that long. It's selling for about $40, $39 right now, and it came out on the market right around this video in June 2022 is when this Bittensor exchange started listing it, because it's not listed in most places, right? And since they started listing it, it started at $5 and it's at $40. So let me ask you this. How does an 8x on your money in 7 months sound? An 8x on your money, right? So if you have, say, $10,000, that's an $80,000 investment right now. You pull out 1/8 of that, you got all your money back, and you still have $70,000 in this project, right? That's in 7 months. Is it hype? I don't know. Is it like there's a lot of development going on? What Matt was saying in the video here around synapses. Synapses are, let me pull this back up here. Synapses are like neurons talking to each other. So in your brain, you have neurons that interact with something, and that exchange of the neuron with the substrate is called a synapsis, right? That's a communication exchange, right? And so they're building this. This is, I believe, out now, in terms of the synapsis, what he is actually talking about right here. And the parachain. So Polkadot has parachains. They're like parallel chains. We can do a deeper dive into like what a parachain is in a future video, but it's going to be living on the Polkadot chain. Like it's a side chain of that. And that just finished like the 13th of December, I believe. So like this is brand new shit, right? That not a lot of people are figuring out yet. But what does the chart look like? Up and to the right, an 8x in 7 months. So I'm not saying you should buy. I'm very excited about it, and I will continue to learn about it. And there's a decent chance I might build a position in it, but that doesn't mean you should do that. You should use this thing and think for yourself. But let's get back into this.
Etc. Etc. There we go. So thank you very much. And if you scan that QR code there, that can take you to links, or you can go to take you to our GitHub.
See the questions. Yeah.
And oh, and one final thing before we go to the questions. If anybody afterwards comes up and the first person to kind of tell me who or what is Yuma Rao, I've got a t-shirt to give away. So
Thank you, Matt. That was absolutely fantastic. I think we should go to any questions that are in the online chat, if there are any.
just someone asking when's the IPO. So you can buy TAO on the it's not available on any public exchanges yet, but people are interested in buying it on the Discord channel. There's a few people that buy and sell sort of peer-to-peer.
So I'm not saying, as I mentioned, you should buy any of this, but the process is cumbersome. I haven't even looked to try to purchase it yet because I want to fully understand what it is and how I personally believe or what I believe is going to take place in the network and going forward. And if you remember when there was the merge on Ethereum, right? We went from proof of work to proof of stake, or 2.0 ETH. During that process, there was two other chains that were created. We have proof of work, the POW network, and Ethereum Fair. Like those are two other networks that are both proof of work, right? The existing chains, the existing chain went to proof of stake, but then two other copies were made, proof of work copy and another proof of work copy called Ethereum Fair. And when that launched, what happened? Well, there was chaos. There was a lot of like people who didn't know how to buy anything on the POW network because it was a cumbersome process. Now it's relatively easy, right? But at the beginning, it is cumbersome and the pieces are not put in place. So there is a Discord for this. Also, oh, I forgot to pull this up. I'll let this play and I'm going to pull up another data point that I looked at yesterday. And I was like, wait a second, is this, because this could easily be manipulated, right? We looked at this, right? This is the price chart. we looked at this, right? But this could be manipulated, right? Like it doesn't take a lot to manipulate a microcap of some sort, right? In terms of price performance, you can, do this with, I don't know the quantity of dollars needed, but you can manipulate this in a bunch of different ways. So there's another data point that I wanted to show you that I will pull up while this Matt goes through and continues to answer these questions.
Here on there. So, and someone's asking when Bittensor Playground. So a lot of these AI tools have what's called a playground that you can go on and you can, type in your query and it comes back with something. We are working on a Bittensor Playground. So we're hoping to get that going. We're getting synapses running first because that's the first precursor to that. And then we'll have a playground going on there as well. But that should allow you to kind of go along and have an interactive play around with it. Or you can, like I said, set up your own infrastructure, set up your own, because it's decentralized. Anybody can connect into the network. But the playground will just make it a bit easier for people. Yeah.
Brilliant. I think because of the time, I really want to get this sort of wrapped up here. So we're going to go to a break. So we're going to finish here, speak to Matt afterwards.
Yep.
I want to say a massive thank you to all.
It sounds like that interaction is over, but I want to show you another thing. It's called Social Blade. Social Blade is a social media kind of like ranking platform that marketers could use, influencers use to kind of like stroke their ego and things like that. And how Social Blade works is you have the platform you can select, and then we have Twitter selected, and then you put in the username, right? And what we put in is the Bittensor Twitter account, right? Because I can look at the network from multiple different angles, right? You can look at it, is the Block Explorer showing a growth in the number of users on the platform, on the network, right? So some of the data that I track might be, say, Zen. Is the network still growing very fast? Is Hex still growing, right? Is Hedron still growing? Is Icosa growing? Like, to understand the network, are the number of holders increasing? Well, if there was a centralized area that is putting out data, you could also track the growth of that centralized thing, right? And Twitter gives us that avenue, right? So Bittensor, right? So this was created in June 2021. So this is 2 years old, right? Or not even 2022, 2023. So 1.5 years old, basically. And you plug in the profile, but check this out. So we come down here. So this is the number of followers, right? In August of 2022, let me see if I can make this bigger so you guys can see this. Hopefully that's more helpful. Okay. So in August of 2022, right? So at the end of August, so we have September, October, November, December, January, right? So five months ago, we had 1,600 followers on their account on Twitter, right? Let's take a gander out to the beginning of December. Beginning of December, we go from 1,600 to 8,000, right? So we have a 6.5x increase in terms of the number of followers. That's bullish to me. That's people are following this account and they're increasing that, as you can see by the slope of the line here, right? From the beginning of December. So we are the 25th of January. So this is less than 2 months later. We go from 8,000 to 18,000. So in less than 2 months, we've had a doubling. In less than 2 months, we've had a doubling in the number of people following us. And remember what I said earlier. It's nearly impossible for the average person to buy some of this because you have to like jump through several hoops to actually go through and buy some of this and find some of this. So this is interesting. Okay. Yes. Thank you, Puri. There is a Discord. There is also a Telegram. I'm in their Telegram as well. If you want to learn more about them, I'd fucking start, getting into their Telegram, get into their Discord, start talking with people about them. Not saying you should do any of like the purchasing of the shit, but I will definitely be looking more into this. Okay. So then I think this is from Medium. We have an article that we wanted to talk about here. This is the Bittensor beating Google at its own game. This is from crypto, whoever this is, September, right? September 1st. So this is like 4 months ago. Building a decentralized market for intelligence. Bittensor is one of those projects that has everything an investor wants to see. A highly skilled team, simple yet ingenious idea for a fair launch. We like fair launches. It has a similar tokenomics to, say, like Bitcoin, except for the incentives are different because there's, let's actually pause here for 1 second. There's an issue with, say, Bitcoin, and there's an issue with Ethereum and a lot of networks. Nodes on the network help increase security and decentralization. So I talked about it here with GRC 8-10 months ago. There's an issue with this on Ethereum and on Bitcoin. There's no incentive for anybody to run one of these things, right? There's no incentive for somebody to run up a node, even though it increases the decentralization of the network as a whole, because all the other nodes in the whole network could go down. But if you have a node up and running, then the network still runs, right? So each new node on the network makes it more resilient and increases security, right? But there's no incentive to do that on Ethereum or on Bitcoin. We're going to be covering a new deep dive topic in a future video. I'm also going to start a deep dive, podcast show once a week on my channel where we go really deep into it. It is called, I don't remember what it's called, but it's another network that is coming out that has solved this issue. But anyways, let's get back to Bittensor. Nodes on these other platforms, they are not incentivized, so not many people do it. When I checked 6-8 months ago, the number of nodes on Ethereum, the second largest cryptocurrency in the world, has 5,000 nodes. Of that 5,000 nodes, nearly 60% are run on Amazon servers. So that means that's super centralized because Amazon can just shut that shit off. Or the US government, who regulates Amazon, can go through and tell Amazon to bend over and grab your butt cheeks. And they can tell them that they cannot use AWS to run nodes for Ethereum, right? That's risky. Well, in this network, there is an incentive to run a node. And it's very interesting, right? We're going to try to understand this more, because if you get the incentives right, a lot of good shit can happen. And that's another reason why I like this, because I pointed this out 8 months ago. I was like, this is a fucking issue. If you don't incentivize people to increase the security and increase the decentralization of the network, it's just not going to happen. It's going to go the other direction, right? There's a reason the government keeps getting bigger, because there's an incentive to get bigger. I've worked in the DoD in multiple different areas, and there's an incentive for people in the government to grow in the government, not to be efficient, not to be smaller, not to be more effective in what you do. There's an incentive to grow the number of dollars you spend, right? So when you create that incentive for them to grow, what do you think happens to government over time? It fucking expands. Duh, right? So when you create an incentive to increase the number of the nodes in the network, you get an increase in decentralization and an increase in security. And that's one of the reasons I really like this. So let's get back into here. Fair launch, token utility, and no big marketing yet. Remember, no big marketing yet, and it's had an 8x in price in 7 months. Today, AI is inefficient, non-transparent, and incredibly expensive. To understand the potential of Bittensor, let's jump 5 to 10 years into the future, where Bittensor will have the most effective and largest neural network in the world, which we'll get into a video explaining what a neural network is in just a moment. It will be decentralized. Various AI companies will validate the quality of machine learning models inside of the network and get rewarded with TAO tokens, native tokens of the Tensor network. Big companies like, continue reading. Why would big companies like Google use Bittensor if they already have their own machine learning networks? Because the centralized AI industry is highly ineffective. Google alone spends 75% of their electrical cost only for machine learning today. Think about that. 75% of all the electrical cost for Google is spent for machine learning. That's pretty incredible, right? So if you do anything in Excel, right? I use Excel often. And a number of years ago, I was trying to run a computation in an Excel spreadsheet. Maybe there's 10,000 data points. And it wasn't super complex. I wasn't doing anything crazy. And it took like 45 seconds to a minute to complete this on 10,000 pieces of data, right? Because the computer is just slow. It's trying to process this 10,000 pieces of data with the formula that I put in on the spreadsheet. Okay, now think about that times like 10,000, right? So now you have, a billion pieces of data, right? But now add on, say, 2 more, right? So now you've got 100 billion pieces of data. And you need this processed in a computer. My computer back in the day, or even this computer here, would take, the next 78 years to process this shit. It just wouldn't do it, right? Even 16 of the same computer wouldn't be able to process this amount of data much faster. It would probably just die, right? So you need a tremendous amount of compute power to be able to fire this off at these things. And that's why I have an idea. So there's two factors that go into increasing the quality and the speed at which AI is going to grow. Right now, data used to be the bottleneck, right, to grow faster. But every single day, the amount of data that is produced and put onto the internet is equivalent to, the entirety of the universe from 1990 backwards, or 2000 backwards in a single day. All the data, print, radio, et cetera, et cetera, et cetera. All of that data all together is equivalent to a fraction of a day's worth of data put on the internet today, right? And so when you want to train something, you need a vast amount of data and a dispersed amount of data to be able to increase the quality of the algorithms for the system. Now, if you want to make a change, you make the change and then you have to run it through the program again, right? And that's super costly. So I think that the bottleneck to this AI growth is going to lead to, when the next 12 to 36 months or longer, probably less, but in 36 months is going to be, the bottleneck to that is going to be compute power, right? And so creating a crypto network where the proof of work type of philosophy, right, the computer's mining, are actually processing the AI, so to speak, from a layman's term of understanding of this. So this way you can have the largest network in the world. Instead of it being on Bitcoin, Bitcoin has way more compute power than Google, right? Way more. It's the largest in the world. Like, it's all other supercomputers, the first 500 supercomputers in the planet, all those combined, all that power combined is still less than the Bitcoin network, right? So now think about all that data that's lost, or the effort that is lost globally, now being applied to machine learning. So I think the other bottleneck is first is data, which they're solving right now. And I think that's going to get solved pretty quickly. And then it's going to be computational power, right? And this network could solve that problem. So let's get back into here as well. Okay. The usage of machine learning models like GPT-3, which ChatGPT is based on, costs $12 million per hour. Fuck. What is that? 12 times 24. That's nearly $300 million a day. $300 million a day to run. Think about that, guys. ChatGPT, 12 million bucks a day, or 12 million bucks an hour. 300 million a day, right? In 10 days, you've got $3 billion of cost on it. This is crazy shit. AI research, and then now think about the nodes actually getting rewarded for doing this and benefiting from this. AI research compounds itself every year, as we looked at. Remember this chart here, right? This is the research that I was talking about, just continues to compound, which we're going to see more and more of as time goes on. AI research compounds itself every year. New models have basically always first to relearn what previous models already learned. So this is important. They will not be able to not at least use the then most effective and largest neural networks in the world as an addition. So how we learn, right, is we use the data out there, and then from our experience in life, and then we get new data in, and we evolve and we change as this goes on, right? Well, with current AI research, you don't have that happening. You have, say, a breakthrough in France, right, in China. Whether they decide to publish that or not publish that, right? That's the first thing. And then say they do publish it. Well, they publish like how they went about doing it. Now, if I wanted to recreate that, I have to start all from scratch at the beginning. Well, the Bittensor network, all that stuff, because how are you rewarded with inflation of the token TAO? By increasing the network's intelligence. So if you increase the network's intelligence by training your node or whatever, and maybe I can try to figure out how to run a node on here. This would be interesting. But training a node so that it increases the value of the entire network by making the network more capable, then you on the other side of the planet, because I did it here in the US and you're in China, you get to see what I did. And you don't have to recreate everything I did to make your model relearn more compute power. You get to see that that's the best one and just utilize that. You're like, oh, wow, that's already done over there. Let me take this and tweak it a little bit with my ideas, my resources, my creativity, and make it even better. So this is one of the areas from an efficiency standpoint that Bittensor really, really solves. Let's get back in here. Scalable and globally distributed. Those are all problems that the Bittensor wants to solve. The open source protocol powers a scalable, globally distributed, decentralized neural network. We're going to get into what a neural network is in just a moment. Several thousand machine learning models work together on different tasks while helping and learning from each other. What I was just saying. Think about this for a second. If you collaborate, if you and I decide to collaborate on something, do you think you'll achieve your goals faster? Or say all of us, right, who are watching this or listening to me, right? What if we all decide to get into a Telegram and we decide to collaborate on something that we all are passionate about? And some people are just like partially passionate about it. So they can contribute an hour a month to talking about it, adding value to it or whatever. And then some people, maybe like me, I put in time every day, and other people like a little time every other day, and other people like a little bit per week, and some people like twice or 3 times a month, right? Do you think we're going to achieve our goals a lot faster? Or do you think we're going to grow a lot quicker? Yeah, no fucking shit. Well, that's what collaboration is. And it's not taking place right now with AI learning. And that is one of the issues with that. By incentivizing collaboration, by incentivizing it in the Bittensor network, you get an increase in collaboration. What does that mean? Increase in speed of learning. A consensus mechanism allows the network to reach consensus on which models are producing information that are valuable and get rewarded with TAO accordingly. There's going to be 21 million TAO There's a halvening every 4 years, just like Bitcoin. Whoever wants to buy reviewed and proven artificial intelligence will be able to do so on Bittensor if they hold enough TAO, because we're going to use TAO to actually buy into it or like utilize it, right? So say the researchers are increasing the value of the network by contributing additional intelligence to the network through their data and through their research, where say a company wants to build something on top of this, like ChatGPT, they want to build this on top of there, they can do that, and they use TAO, the token, to actually do this. So we're at such an early stage of this that people haven't fully grasped the power of like how AI is going to impact the world in the future, and how this is going to everything you do is going to be touched by AI. The founders and brains behind Bittensor have both worked on the dark side of the industry. Jacob Steves has worked in enterprise machine learning at Google and ALA, whatever this is, at IBM. They built a team of currently around 10 AI developers to build Bittensor, but are already planning to expand the team this year. Tokenomics and token utility. The value of TAO is connected to the value of the intelligence. Let me reread that. The value of TAO is connected to the value of the intelligence that is produced by the network. Ownership of the network comes with holding TAO. So if someone holds a fair amount of TAO, he gets to decide on what the network will be trained on. So this is also like a multimodal. You can train AI in multiple different ways. And if you think that like just one way is the best way, like you get into that closed-mindedness of that's going to hold a lot of people back in just life, right? Because they think, oh, this is the only way to do something, and they don't like expand their mind to think outside of the box and realize that there's multiple different ways to make $1 million. There's multiple different ways to, feed the world. There's multiple different ways to achieve whatever dreams and aspirations you have for your life, right? And so by having multimodal approach to machine learning, you can, hey, ask the network to train better on XYZ, say videos for something, right? And then the entire network is now incentivized to train better machine learning models for video, right? And then somebody was desire to learn more about, whatever large language models for something, right? Well, that learning that took place around video has some applicability to large language models. And that learning can be utilized over here so that this can learn more effectively and faster. Super, super interesting. Gets us out of network. Okay. If an external company wants to use Bittensor, for example, to develop a specific software, it needs TAO tokens. In order to have the request bandwidth to make the application worthwhile, a certain amount of TAO is needed. Also, the miners and validators of the network are incentivized with TAO. The tokenomics are inspired by Bitcoin. The max supply is 21 million tokens, and every 4 years there's a halvening event. The first will be on the 25th of or 2025. The current issued supply is around 2.7 million TAO. I'm going to check the Bittensor. Let's see here if they have the total supply up here somewhere. I thought I saw it somewhere else. I think it's over 3 million now, because at the beginning stages you have like hyperinflation, just like Bitcoin. And micro market cap was around 100 million. It's doubled that. It's more than doubled the market cap of this now. Polkadot ecosystem in Q4. Currently, you can buy TAO only on an external exchange run by a third party by swapping with Bitcoin, or on the Discord of Bittensor via OTC by swapping with USDC. I would recommend the latter, as the prices are cheaper over there and you can use middleman. I don't know why using a middleman is like an intelligent thing to do, but there are cheaper prices. So apparently, I think somebody was mentioning the Discord, Pierre, You were mentioning the Discord, so you can probably buy over there, and it sounds like the prices are cheaper over there. By the end of the year, Bittensor will be integrated into the Polkadot ecosystem, and TAO will be listed on various dexes. So this would be dope and allow us other places to buy if that's where your prerogative is, so that you can swap TAO also with other cryptocurrencies. Where Bittensor stands today. In a podcast in May, the founder said that the projects was still in the people are laughing at us phase. Interesting, because you had an 8x in value in 7 months, meaning that bigger companies in the AI industry are still critical and first want to observe what the newcomer can do. Okay, so this would be like wine snobs thinking of like me talking about wine as like, oh, this foolish child doesn't know what he's talking about when it comes to wine, because I'm like, oh, this shit tastes like garbage, right? That's probably what he meant by that. Bittensor is currently focusing on building the network, training its models, and getting to a state where they can prove their competition what they are capable of. So as investors, this is a good time to get in slowly. This will be interesting. Now think about like a chat GPT that was like powered by the people, and not all the money was flowing of OpenAI from licenses and from people, users, right? Like think about like it flowing to the network. Think about that, where a service built on top of the Tensor network, the money was going to a bunch of different places. I don't know. This is interesting. I'm going to follow this shit. This is like, I don't like, I was waiting to find different projects of things that I find very interesting. And this is one of the ones that I currently find very interesting. Investment thesis. I will definitely add some TAO to my portfolio. Probably I will DCA into it and try to buy dips. The price has risen extremely in the past weeks, and many early investors have started to sell large quantities. You can buy TAO for $5 to $10 weeks ago, which we looked at the chart. So this is from 3 months ago, and it's gone up from then. I will hold the token until the first institutions will start to use the network in the coming years, and we'll be happily to sell to them, blah, blah, blah. Notable partnerships: Polygon Capital, Digital Currency Group, and First Mark Capital Investor in Bittensor. If you're enjoying content, okay, so that's pretty much it. DAO. Bittensor is working out plans to create a DAO on the Polkadot chain for next year. The main goal of the DAO is to create sub networks. So this is how this is one way that they scale so people can actually use this. Sub networks and set of executives that run those networks. People that hold TAO will then have the possibility to buy into the DAO and determine how the system will move. The DAO, hopefully it takes some cues from Cult. Cult, I think, was structured in a fairly effective way, and use that as like a template to improve on. The DAO will also control over what problems Bittensor will solve. Updated OTC channel deleted. Since the OTC trading channel of Bittensor blew up in size and in preparation to the upcoming DEX release, the team deleted the OTC trade channels today. With this step, the team wants to assure not to violate security laws. Okay, so that's interesting. What do you guys think about this? I want to show you what like a neural network is. This is probably a very simple version of like what a neural network is. Like, what do you think about this stuff? What do you think about AI and all this? I use AI every day in my business. I have a team member who works for me who uses AI, and I have him using AI every day.
Visited Russia. Even though none of us could read Russian, we did not have any trouble in figuring our way out, all thanks to Google's real-time translation of Russian boards into English. This is just one of the several applications of neural networks. Neural networks form the base of deep learning, a subfield of machine learning where the algorithms are inspired by the structure of the human brain. Neural networks take in data, train themselves to recognize the patterns in this data, and then predict the outputs for a new set of similar data. Let's understand how this is done. Let's construct a neural network that differentiates between a square, circle, and triangle. Neural networks are made up of layers of neurons. These neurons are the core processing units of the network. First, we have the input layer, which receives the input. The output layer predicts our final output. In between exist the hidden layers which perform most of the computations.
This is a super simplified version. Like I have a Tesla and I just got full self-driving, but the hidden layers that he's describing right here might be like tens of thousands or hundreds of thousands of layers
Required by our network. Here's an image of a circle. This image is composed of 28 by 28 pixels, which make up for 784 pixels. Each pixel is fed as input to each neuron of the first layer. Neurons of one layer are connected to neurons of the next layer through channels. Each of these channels is assigned a numerical value known as weight. The inputs are multiplied to the corresponding weights, and their sum is sent as input to the neurons in the hidden layer. Each of these neurons is associated with a numerical value called the bias, which is then added to the input sum. This value is then passed through a threshold function called the activation function. The result of the activation function determines if the particular neuron will get activated or not. An activated neuron transmits data to the neurons of the next layer over the channels. In this manner, the data is propagated through the network. This is called forward propagation. In the output layer, the neuron with the highest value fires and determines the output. The values are basically a probability.
There's also backward propagation as well, so you can learn from what other people are doing in the network, similar to, say, how humans would learn from, say, other people. So if you connect to the Bittensor network and you add intelligence to the network, right, by making the ML or AI better, what happens is I'm able to query that and learn from you. And we didn't even get into the incentive structure of how mining works, because that's also a little bit different as well.
For example, here, our neuron associated with square has the highest probability. Hence, that's the output predicted by the neural network. Of course, just by a look at it, we know our neural network has made a wrong prediction. But how does the network figure this out? Note that our network is yet to be trained. During this training process, along with the input, our network also has the output fed to it. The predicted output is compared against the actual output to realize the error in prediction. The magnitude of the error indicates how wrong we are, and the sign suggests if our predicted values are higher or lower than expected. The arrows here give an indication of the direction and magnitude of change to reduce.
So I believe this is called supervised learning, and I got another video in a second. I don't know if we're going to get into all this stuff I wanted to cover today, because I've been talking a lot.
The error. This
that video talks about supervised versus unsupervised.
Information is then transferred backward through our network. This is known as backpropagation. Now, based on this information, the weights are adjusted. This cycle of forward propagation and backpropagation is iteratively performed with multiple inputs. This process continues until our weights are assigned such that the network can predict the shapes correctly in most of the cases. This brings our training process to an end. You might wonder how long this training process takes. Honestly, neural networks may take hours or even months to train, but time is a reasonable trade-off when compared to its scope. Let us look at some of the prime applications of neural networks. Facial recognition. Cameras on smartphones these days can estimate the age of the person based on their facial features. This is neural networks at play, first differentiating the face from the background, and then correlating the lines and spots on your face to a possible age. Forecasting. Neural networks are trained to understand the patterns and detect the possibility of rainfall or a rise in stock prices with high accuracy. Music composition. Neural networks can even learn patterns in music and train itself enough to compose a fresh tune. So, here's a question for you. Which of the following statements does not hold true? A. Activation functions are threshold functions. B. Error is calculated at each layer of the neural network. C. Both forward and back propagation take place during the training process of a neural network. D. Most of the data processing is carried out in the hidden layers. Leave your answers in the comments section below. 3 of you stand a chance to win Amazon vouchers. So Don't miss it. With deep learning and neural networks, we are still taking baby steps. The growth in this field has been foreseen by the big names. Companies such as Google, Amazon, and NVIDIA have invested in developing products such as libraries, predictive models, and intuitive GPUs that support.
Well, that will be interesting, but I think we're going to run out of time. So hopefully we can get a little bit into supervised versus unsupervised learning here with this video here.
An easy way to begin grasping the concept of supervised learning is by looking directly at the words that make it up. Supervise means to observe and direct the execution of a task, project, or activity. Obviously, we're not going to be supervising a person. Instead, we'll be supervising a machine learning model that might be able to produce classification regions like we see here. So how do we supervise a machine learning model? We do this by teaching the model. That is, we load the model with knowledge so that we can have it predict future instances. But this leads to the next question, which is, how exactly do we teach a model? We teach the model by training it with some data from a labeled data set. It's important to note that the data is labeled. And what does a labeled data set look like? Well, it can look something like this. This example is just taken from the IRIS dataset, which is a famous dataset used for machine learning. Let's start by classifying some components of this table. The names up here, which are called sepal length, sepal width, petal length, petal width, and species, are called the attributes. The columns are called features, which include the data. If you look at a single data point on a plot, it'll have all of these attributes. That would make a row on this chart or an observation. Looking directly at the value of data, you can have two kinds. The first is numerical. When dealing with machine learning, the most commonly used data is numeric. The second is categorical. That is, it's non-numeric because it contains characters rather than numbers. In this case, it's categorical because this data set is made for classification. Usually,
So Google actually started, no, Tesla was using supervised learning initially, and now they've switched with their Dojo, which is like their supercomputer, to unsupervised, where they can query the system to pull instances and have it self-labeled. So if you think about supervised learning, because we're going to run out of time here, supervised learning requires the data to be labeled. All right, so this is a fucking mason jar. So I labeled a mason jar, right? And that means there's human input. And if you have billions of data points, right? Like you have to have a pretty big team, even you're working 24 hours a day to be able to label billions worth of data, right? And so that becomes a bottleneck. So to get around this, what Tesla did, and then this type of stuff is going to be implemented with Tensor, right? Is that you can query the network of cars. You can think of the car as like a node or neuron, like on the tensor network. They can query that network to see what is, say like there is a sheep falling out of the back of a pickup truck, right? And that's not something that the Tesla AI has experienced before, right? So it doesn't respond to that very well. Similar to the example of like a circle input. Is this a circle for the neural network to predict? And it says square. No, it's not the fucking square. It's a circle, right? So what Tesla did is it created this query system that does it automatically. So anytime that like I'm driving and the AI sees something that's an issue, right? It can grab that data that could all go back to the network, and in the network, it sees like, okay, well, there's this type of problem that's going on here. Let's take this sheep falling out of the back of a pickup truck and query the several million vehicles we have on the road and new cars going on the road every single day to see if we can find other instances of a sheep falling out of the back of a pickup truck. So then you get dogs falling out of the back of the truck. You get pigs. You get all these different instances of things coming out of the back of a pickup truck, right? So then you get this. There was one data point, and you just queried the millions of cars to now understand, okay, here is a data set of 400,000 different examples of shit falling out of the back of a pickup truck. And then they start training their AI on that, because now you have a data set to train it on to improve it, right? And so you just do this iteratively over and over and over again. But that way it can self-label this stuff versus like the supervised learning. I have to go in there and say, oh, this is a mason jar, or oh, that's a sheep, that's a truck, that's a road, there's a side of the road, there's a side of the road, there's a tree, right? You have to label everything in the scene there, right? There's a plant there, there's a sign there, there's some type of color thing over here. It looks like there's something like right there. It looks like there's something over there. There's something in the middle there, right? And you have to have everything labeled. The unsupervised allows the system to get better without that type of supervision. And there's different degrees of supervised or like unsupervised learning, right? The less the input, right? You consider that unsupervised, but there might still be some type of input involved, just not the traditional type of input. Well, that kind of wrapped things up. There was still other stuff that I wanted to get into in this, but maybe we can cover that in a future video. GRC is actually going to be back tomorrow morning, 11 a.m. So if you guys enjoy the content, jump over to Twitter, jump over to Instagram, say what's good. What do you guys think about the Tensor Network? Do you think this is like something valid? Do you think this is another one of those projects that's going to fizzle out and there's like hype behind it and stuff like that? Do you think it's valid? How do you see this playing out? I'm curious to hear what you think. Let me know down below in the comments, or jump over to Twitter or on Instagram. Links down below. We're going to take ourselves out of here with some DeFi proof. Peace. See you tomorrow.
You already know what time it is. Crypto in the morning. Crypto in the morning. Crypto in the morning. Waiting on phone. Crypto in the morning. 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 Waiting on phone. Crypto in the morning. Crypto in the morning. Smoking a blunt on my way to the gym. 11 a.m. and I'm already tuned in. Got me some hacks and I'm making a stake. Got me some heads on, I'm making it rain. Pay me some maxi and that's just in case. Gym ready to set me to show you the way.